What's up, guys? This is Dr. Molly Gray here, physical therapist. We're recording this seminar again for your enjoyment. So today we're going to talk about biomechanics and how to safely modify and progress your workouts. So I'm doing this in conjunction with Uplifters. I'm the owner of 48 Physio. I'm from Crestview. You guys probably already know me by now, but it's an honor to be here. I've worked in a variety of different healthcare models and I just decided to start my own thing so I can do exactly what my clients need. And one of those things is deep diving into education like this. So let's get started. The goals of this seminar, I hope that overall, everybody who comes into contact with me or any of our team members would walk away with an improvement of knowledge in general about their body and how it works, the functional knowledge of how it works during specific movements. So during this seminar, we're going to dive into that pretty deeply. We're going to look at some basic biomechanical principles, as well as how to modify or progress some of the workouts and the movements that you're doing. And hopefully you'll walk away with a little bit more confidence, knowing that modifications do not mean setbacks. So biomechanics, diving right in. Biomechanics is just a big fancy word, but it basically just means that it's the way that your body moves. And there are a lot of benefits of having proper biomechanics, which you can read here. Understanding biomechanics is the foundation for good technique in all sports. And even if you're not in a sport, if you're participating in CrossFit or a HIIT workout or any sort of weightlifting, cardio, you're doing an athletic activity, which makes you an athlete. So it's really important that you understand your body and how it moves. We can naturally remove stress and pressure on your body, the bones, joints, muscles, and ligaments using appropriate form, which leads to improved performance and definitely reduced injuries, which is a huge component of what we do, obviously. So that's what we're going to focus on specifically for lifting. Lifting mechanics, if you've ever worked in a place like Publix or somewhere that has boxes that you have to lift, they probably have made you go through some sort of lifting mechanics training to reduce your risk of injury. We do want to make sure that during workouts, you're following all of those rules as well, because we want to reduce your risk of injury during the workouts. Overall, the goal is efficiency. So in general, there are a few principles that you want to follow when lifting. Always standing as close to the load as possible. So during a deadlift, you're going to stand really, really close to that barbell. You're going to bend at your knees and not at your waist. This doesn't necessarily apply to everything. So obviously, like for a squat, you're going to have to bend your waist. You want to make sure that most of the time when you're lifting a heavy, awkward load, you're using your legs and not rounding at your back. That's what that bullet point is referring to. You're going to hug the load close to your body and not away from you. So again, standing as close to the load, holding the load as close as possible, and then using your strong thigh muscles. That's that, going back to that second bullet point. Our legs are meant to lift things and not our back. So the spine is basically there to help support your organs, and obviously movement occurs at the spine. But many different postures can produce a change in the geometry of the spine. So during those movements, the actual shape of the spine changes. So the lumbar spine goes from being lordotic to kyphotic, and then back to lordotic when you stand up and pick something, when you bend down and pick something up. So it's just important that the muscles surrounding that area are nice and strong. So again, overall, the goal is efficiency. Using your legs is more efficient than using your back. So efficiency, what is it? It's the state or quality of being efficient. So we're being, competent in our performance, and we're able to accomplish the job with minimum expenditure of time and effort. So this is basically talking about the physics of efficiency. Efficiency is key to ensuring consistent performance, which again, we're going back to reducing the risk of injury. So in a nutshell, it's the ability to perform the least amount of work in the quickest amount of time to achieve the desired result. So there are 5 different concepts that we're going to consider to improve efficiency. So if you're going for a 1 rep max, or if you're doing, just a traditional workout, you want to be as efficient as possible with both of those things. So the different keys to efficiency. The first one is center of mass. And a lot of this goes back to physics, okay? But you got to think about the fact that our bodies are basically machines. So we think about our center of mass, which is the point where the object, where the weight of the different segments in an object are centered on. So in weightlifting, we need to make sure that we keep our center of mass of the barbell connected to ourselves. So that way the barbell and our cells in our bodies can move together as a system, and the force can appropriately be transferred from our bodies to the barbell to create movement in the barbell. So once you touch the weight, whether it's a barbell, dumbbells, kettlebell, whatever, that weight becomes part of your system. So your center of mass changes when you're lifting weight. The second key is your base of support. So if you've ever heard a trainer say, keep your feet shoulder width apart, or make sure that you spread your feet nice and wide, that's talking about your base of support, which is the surface area in contact with the floor most of the time. If you're doing a handstand, your base of support is going to be your hands. If you're doing a plank, your base of support will be your toes and your elbows. So understanding the concept of base of support is super important, because we want to keep the center of mass over the base of support at all times. If we lose that concept, so if the center of mass travels outside of our base of support, that's when we lose our balance, and we have to expend more energy to reestablish balance. So again, going back to efficiency, we're trying to make things move with the least amount of energy as possible. The third one is the ground reaction force, which is basically the force that's required to overcome the barbell. So it's inertia. So we want to make sure that we're using our legs, being flat-footed, because we're able to produce more force, more ground reaction force to transfer to the barbell through that concept. The fourth one is displacement. Displacement is the shortest distance from the initial position of the barbell to its final position. So let's say you're doing a barbell snatch. The shortest distance from the floor to get it overhead is what you're trying to achieve. So we're going to think about the more horizontal or back and forth displacement that you have, the less efficient you're being, and the less horizontal displacement you have, the more efficient you're being. So you want to try to move the barbell as vertically as possible during a snatch. This same concept applies for a squat, for a deadlift, any movement where you're trying to lift the weight from the floor to overhead or to shoulder height. You want to think about vertical versus horizontal displacement. Our goal is vertical. The last one is velocity, which is basically just speed or displacement over time. So that determines the amount of force that's required to move the barbell or move the weight. The longer it takes to move the barbell's position, the more force is required to achieve the displacement. So basically the top speed needs to be reached shortly after your initial movement in order to achieve your goal. If you can have more speed before nearing the end of the range of motion, then your peak velocity can be easily attained in the initial movement, which means that you're going to be more efficient during the rest of your lift. Then I added an extra one here, having a plan. So all of these, physics concepts don't mean jack squat if you don't have a plan. So that's what we're going to talk about next. So picture this scenario. Okay, it's Monday. You walk into the gym after a weekend full of fun. You guys went to the beach. You're already feeling a little tired and fatigued. Your calves are sore from walking on the sand, and your hamstrings are pretty tight from playing frisbee with the family. Today's leg day, and there are lots of squats, lunges, burpees, box jumps that are programmed for your workout this Monday. So you're thinking, okay, I got this, no problem. But then you start to think a little bit more, and your body's telling you, whoa, let's slow down and think about this. So here are some choices. What do? A, you ignore your brain and listen to your body. You decide to go home and rest. You don't even try. Are you B, ignore your body and listen to your brain? You decide to go all out and you just give 100% effort the entire workout. Are you C, maybe you feel a little confused and too tired to listen to either what your brain or your body is telling you, and you just kind of go through the motions of the workout with about 50% effort? Or are you D, because you've participated in this seminar, you feel confident and you know how to modify the movements that put you at risk for injury? This means you'd be 100% efficient. Okay, so obviously I hope everyone would answer D, and that's the whole purpose of this seminar. So just because you have to modify something does not mean that you are setting yourself back, okay? Modifications are basically making movements a little bit easier or safer for you to perform. A progression is making a movement more challenging or harder for you to perform. So just because you're doing one or the other does not mean that you're better or worse than the person next to you, okay? So try using some of these questions to see if you need to modify or if you need to progress. Are you able to maintain proper form? If not, why not? Is the exercise causing pain, or is it just a little uncomfortable? Like, burpees are hard for everyone, hopefully. Are you in pain? Is the weight too heavy, or is it a lack of mobility? How quickly are you moving? Could you do this movement if you slowed down a little bit? Or do you think you could do it if you moved even faster? Are you having to think a lot about the movement, giving yourself cues, or is it just second nature? Could you do it in your sleep? How familiar are you with the movement? How confident do you feel? Can you maintain proper form? Is the speed of your movement appropriate? Form is way more important than weight, okay? Always, always. And then the last one, which is probably my favorite question: could you explain and demonstrate the movement appropriately to someone who has never stepped foot in the gym before or seen that movement done before? If not, that probably means that you need to modify or at least ask for some clarification about the specific movement that you're doing. And if you could explain it to someone, that's awesome. You can either continue with what you're doing, or it's probably time for you to progress and challenge yourself a little bit more. So finally, part of your plan should be to have appropriate accountability. We want to make sure that the people next to you in the gym, or your workout partner, or however you're working out, are encouraging you, but also reminding you of your limits sometimes. Modify when needed. Again, it is not a setback to modify an exercise. You're going to achieve your goals faster in the long term if you are able to modify, do an exercise appropriately, safely, with appropriate weight, great form, than if you choose not to modify and do the workout that's unsafe or with bad form. Self-awareness, how are you feeling today? How has your weekend been? Kind of back to that scenario on Monday. Asking questions. At Uplifters, the trainers are super knowledgeable. I'm there most of the days. You can always ask me. If you go to a different gym, or if you're working out at home, Google is a great place to ask questions. Not always, but in general, you can at least find some sort of information that can help you. And just remembering that form or biomechanics is way more important than weight, and then prioritizing your recovery. So things like stretching, maintaining your mobility, staying hydrated, getting a good night's sleep, all those types of things are super important for performance. So let's get to the fun part. Now we are going to talk about the biomechanics of the deadlift and squat. So these are both complex movements. There's a lot of different joints going on with these types of movements, and they're pretty common. Even if you're not doing a barbell deadlift in your workout, you're going to be doing hopefully some sort of hinging motion at your hips at some point during your programming. Same thing for the squat. A squat is a pretty basic movement. If you're not doing barbell squats, you're probably using a dumbbell or body weight squats or some sort of lunge. Those types of movements are usually pretty common. So we're going to talk about the squat first. So here we have some examples. So the squat starts with a descent phase as the hips, knees, and ankles all flex, okay? So a common cue is to descend until the thighs are parallel with the floor, or that your hip joint is parallel or below the knee joint. And then when you stand back up, it's performed primarily through what's called triple extension of the hips, knees, and ankles. That all happens at the same time, that extension, until you return to standing. So we're going to categorize the squat into 3 domains. So there's going to be upper body, lower body, and then movement mechanics. So upper body is going to emphasize stability, posture of the head, neck, torso, core involvement. The lower body, we're going to look at joints of the hips, knees, and ankles for that triple extension that we talked about. And then the last part, the movement mechanics, is going to be to assess the timing and coordination of the exercise overall. So let's start with the upper body. So as you can see in figure 1, subject A does a really great job of keeping his head in neutral. So an incorrect head and neck position can result in improper spinal positioning throughout the movement, not just in the neck, but also in the thoracic and lumbar spine as well, and your sacrum. It's been shown that both the head and neck position can influence spinal kinematics, which is where your body is in space. So, for example, you can see subject B, he's looking up during his squat, and he has excessive cervical hyperextension, which means he's extending his neck, basically, probably to compensate for a lack of mobility in his thoracic spine. And you can see what happens to his lumbar spine. The green line is a little deceptive, I think. His spine is not actually straight. He's having some pretty significant lumbar lordosis, excessive lordosis at the bottom of his squat due to lack of mobility. Alternatively, if he was looking down too much, that might result in a tendency to extend his lumbar spine, which can increase compression forces. So that's on your discs. So it's super important that you keep your head in a neutral position in relation to the spine, with the neck held in line with the plane of the rest of your spine or your torso. Although head position and gaze are related, it is super important to recognize that they are independent of each other, meaning that you can keep your head in neutral and still look up, or you can choose to look down. So gazing straight ahead or slightly upward is usually recommended, but that doesn't mean that you have to move your neck in that position. So we want to make sure that the differentiation between looking and head position is clear. Slightly upward is usually pretty good. The torso. So squatting with a more vertical torso increases your load onto your legs, basically your quads, resulting in reduced lower back stress. So when you hear people say, keep your chest up, that's the cue that you'll usually hear for that. Maintaining your upright trunk as much as possible reduces the shear forces, specifically in the lower lumbar spine. So we want to make sure that the general guideline to ensure your posture is to keep the line of your trunk parallel to the line of your tibia. So your tibia is your shin bone. So you basically want to think about the 2 lines. Subject A does a great job of that. The 2 lines from your back and your tibia, we want those lines to be as parallel as possible. That's going to look different for everyone because the length of your femur plays a pretty big role in that. But that's a really great cue. So if you're checking your buddy's form, you can think about the line from their spine and the line from their tibia. Those 2 lines should be parallel. So someone might have to lean forward a little bit more if they have a longer femur length. But again, their ankle mobility should be that allows them to have those 2 parallel lines. So both subjects A and B in figure 1, they're able to keep a generally neutral spine. Squatting with a flexed lumbar spine decreases the moment arm for the erector spinae, which are those stabilizer muscles on either side of your spine, which reduces tolerance to the compressive load of the spine, which happens when you do a back squat or a front squat, resulting from the transfer of load from the muscles to passive tissues like ligaments, discs, things like that. All of that is a fancy way to say that you're going to get injured if you squat with your back bent. Okay, so you want to think of performing this squat with a stiffened torso, keeping your core nice and engaged, in a neutral spine. So there's usually 3 different categories that we can put squats into in terms of depth. So partial squats have about 40 to 45 degrees of bend at the knee. Half squats, somewhere between 70 to 90 degrees at the knees. And then deep squats, which are greater than 100 degrees at the knee. So performing a full squat, obviously you have to have the knee mobility to do that, but it actually comes from your ankles. So we need at least 15 to 20 degrees of ankle dorsiflexion and 120 degrees of hip flexion in order to be able to perform a deep squat. Dorsiflexion at the ankle is when you bring your toes up. Plantar flexion is when you stomp on the gas pedal. So we want to have dorsiflexion for a squat. It's pretty well known that people who have poor ankle dorsiflexion are at greater risk of injury because of the lack of mobility that it leads to in the hips and knees, especially during functional movements. So we want to make sure that we pay close attention to that during the days when we're stretching and working on mobility. So stretching your posterior ankle musculature includes your gastrocnemius, your soleus, a few other muscles, basically just taking care of the back part of your calves will help increase that range of motion. You also want to make sure that you can have an increase in the anterior tibial translation. So if you ever see drills that people have bands around their ankles and they're leaning forward and trying to do a deep lunge, that's a great mobility drill to do to increase your ankle dorsiflexion. That's going to allow your torso to be more upright. You can see the angles here in figure 2. The first subject, he's got 125 degrees of knee flexion and 24 degrees of ankle dorsiflexion. That allows him to get pretty deep into his squat. His form looks a lot better than subject B, although subject B is still doing an appropriate squat. But he only has 9 degrees of ankle dorsiflexion, so significantly less. And you can see that that does not allow him to squat as deeply as subject A. So he's still doing a pretty good squat, but we like to see deep squats because that generally means that you have greater mobility, greater control over your muscles in that position. So there's lots of different things that you can do to improve the depth of your squat. So let's try it. We're going to go to the next slide. So if you want to stand up, you can try this on your own just for fun. Videoing yourself from the side is a great way to see how you're moving. Just keep these points in mind as you squat. And then tips to improve your squat. You're going to improve your ankle dorsiflexion mobility, which we talked about. Improving your balance, increasing your core strength. All of these things are super important. Obviously, working with a professional will help. If you're not able to squat to the depth that you would like to, you can modify the squat by trying a TRX. So you'd hold on to the TRX straps, and that will allow you to kind of sit back and then use the straps to help stand up again. You could do box squats, which is where you sit back as if you're sitting onto a chair, and then using a exercise ball behind your back to squat down on the wall. You can also elevate your heels. So by standing on a weight plate, or they make specific things for you to actually do this on, but that basically will help improve your ankle dorsiflexion not actually because you're standing with your heel elevated, but it functionally does the same thing. So in the notes section, if you download the notes to this presentation, I've got a ton of different example exercises that you can do to help improve your squat depth. All of those would be considered modifications. So moving on to the deadlift, very different than the squat. In contrast to the squat, we start with the ascent instead of the descent, and all of your hips, knees, ankles are extending instead of flexing. So it's basically like a reverse squat. So two common styles are conventional and sumo. Sumo has different mechanical advantages because you're allowed to keep your torso more upright, which results in less back shear. However, the conventional style requires increased energy expenditure, up to 40% higher, actually. So it just depends on your goals. If you're trying to lift a ton of weight, going for a 1 rep max, that's usually why you see people do a sumo squat for heavier weight versus doing a conventional deadlift. That would be probably more common that you would see in like a CrossFit workout or something like that, because you're trying to burn a lot more calories. So starting position, you're going to scoot nice and close to that bar with the barbell close to your shins. You want to try to keep your feet shoulder width apart. So that goes back to those physics principles that we were talking about: base of support, center of mass, all those things. You want to try to keep the bar as close to your body as possible during the entire lift. So you can see in figure 5, both subjects do a really great job of that. The blue and red lines below the barbell indicate the path of the bar. So subject B, that's like super straight path. Subject A is also very straight. There's a slight divot up here at the top of the movement, which could have been due to a number of things, but we'll get to that. You want to start with your back angle about 45 degrees, but again, that's very dependent on how you're built. So if you're a lot taller, that's going to look a little bit different. You might have a little bit more of a bent over posture greater than 45 degrees. If you're a little bit shorter, you can probably get something less than 45 degrees. This goes back to your femur length. So you look at subject A from figure 4, he's a little bit shorter than subject B, it appears. Even if he's not shorter, his femur length is probably a little bit shorter. So he is able to achieve a little bit more of a horizontal back position compared to the floor. But basically, you want to start with a bent back position. Subject A, again, does a really good job of keeping his head in neutral, while subject B is hyperextending his cervical spine, which affects the rest of his spine. So would not recommend that you look up during a deadlift. Try to keep your head in neutral as much as possible. So your shoulder blades, those should be on the top of the bar, just nice and straight over. This is the most effective technique. It's going to keep you most efficient. This is because the shoulder blades generally transfer the force generated by the legs into the back and onto the bar. So in order to be more efficient, you want to keep that line as straight as possible. A vertical line similar to that of gravity is going to be the most efficient. So you can see that in both subjects. They do a good job of that. The end position is to lift the bar, and then you basically stand up and hold it, right? So when comparing the bar paths of subjects A and B in figure 5, you can see that the vertical path of the bar is straight up and down, which is what you want. So that little top wiggly part that we talked about at the beginning that subject A has, that just demonstrates a little bit of posterior horizontal displacement of the bar, which means it moved back, which is probably due to the bar rolling down his thighs. So just because that might look less efficient, he was able to do that because it allowed the bar to remain close to his body as possible. So it just depends on your anatomy. If you have bigger thighs, that might happen. So trying to think about cueing, you want to think about squeezing your glutes at the top of the movement as hard as you can. keeping your abdominals really, really tight. So breathing out as you're standing up, all of that is going to help keep your pelvis in a neutral position and reduce the risk of injury. So let's try it. You can stand up and give these different points a try and see how it feels compared to what you would normally do for a deadlift. So it's a hip dominant movement rather than your legs. So a lot of people get this wrong. They just kind of go into a squat up and down. You want to think about moving your hips back first, which is called a hip hinge. So it's about the ability to push your butt back and then drive your butt forward with your glutes. And that all needs to happen with a neutral spine. So another thing to think about is the grip. So you can do double overhand grip, which is technically safer because it's symmetrical, or you can do the mixed grip, like one palm facing up and another facing your body, which is technically not symmetrical. However, it's stronger grip. So it just depends on your goals. The first rep is always the hardest because of physics. You're having to pull that barbell from a dead stop compared to the other reps because the body in motion tends to stay in motion. And you want to just keep your core nice and tight. Make sure that your hips and glutes are engaged the whole time, especially your hamstrings, creating tension in your shoulders, pulling your shoulder blades down and back, and you'll have a great deadlift. So another common misconception is that deadlifts are bad for your back, and that is not true at all. They're actually excellent for your back. It's just a much more complicated movement than people realize. There's a lot more going on than a lot of people think at first look. So as long as you're keeping these points in mind, there's very little risk of injury. So to improve your deadlift, again, you want to improve your ankle dorsiflexion because of that starting position. Improving your balance, increasing your grip strength is a huge one. I love to watch videos of professionals deadlifting because you really start to see the movement pattern is pretty foundational, regardless of every person's different anatomy. So that's a great place to start. Modifications to try or to add to your workout. I put a few options here. You can do partial range of motion kettlebell hip hinges against the wall to really make sure that you got that first hip hinge movement down pat instead of a squat. So if you struggle with squatting versus deadlifting, that first one is going to be great to do. You can elevate the barbell if you have poor ankle mobility or poor hip mobility. That way your range of motion is reduced. You could do a banded deadlift. That way you have tension throughout the entire movement. You'll be able to notice some different areas that need improvement compared to others. You could do some pull-throughs, bridges, hip thrusts. I mean, the list is super long. I have even more in the notes section. So that was it. Thank you for listening. All of those tips and tricks, I mean, we flew through that pretty quickly, but it's all pretty detailed stuff. So if you have any questions, please do reach out. I'd love to do a one-on-one session with you. Our trainers would love to do that as well. Just taking the time to go through and looking at your biomechanics for things like a squat and a deadlift will significantly improve your performance, reduce the risk of injury. You're going to feel more confident during your workouts. It's extremely beneficial. I'm also going to be releasing the quick guide to exercise modifications and progressions, which goes over way more than just the squat and deadlift. I think there's close to 50 exercises in that guide. So I will have that uploaded onto the website very soon. But if you have any questions, please reach out. Our contact information is right there. Thank you so much for watching.